So in the periodic table of elements, what we have to worry about for biology are just three things is what we want to know. Well, technically four. But the protons, the number of neutrons, and the number of electrons. Protons, very simple. The atomic number, so lithium is the atomic number. So in lithium, for example, it's 3. If you would take away a proton and only have 2, now it's no longer lithium, but helium. So our atomic number always equals the number of protons. Okay, the electrons, similar but tricky. Normally, it equals the atomic number. So again, with lithium, it's going to be 3 as long as there's no charge. If there's a charge, so if it's lithium plus 1 on its charge, now we have to use a formula. It's the atomic number minus the charge equals our number of electrons. Okay, so in our lithium example, we have 3 minus a plus 1, so that equals 2 electrons in that. Okay, where it can get a little tricky is when we come to this side of the periodic table, where we generally have negatives. So TV timeout. So if we're dealing with, say, an oxygen molecule, that's usually got a charge of -2. So to find our number of electrons, we do our atomic number, which is 8, and then we subtract our charge, though, is -2. So for chemistry, when it comes to this, these 2 negatives end up, meaning you add. So when we have 2 negatives, we add. The 8 and 2 means 10 electrons when our oxygen is in a -2 state. That's what we need to remember, okay? Neutrons, a little bit simpler. TV timeout. So our neutrons, we do still use our atomic number, so that's an important element here, or important portion of how we figure out within our elements what the number of protons, neutrons, and electrons are. But let's look at our lithium. The 3 things we need is the atomic number, which with lithium we know is 3, but then we also need the atomic weight, which here is 6.91. For our purposes in biology, sophomore for required, we're going to round this either up or down, whichever is closest. With 6.9, the closest rounding is 7. So we take our atomic weight, always a whole number. Must be a whole number. So this time it's going to be 7. So we've got, in our case, we've got our atomic weight of 7 minus our atomic number, which lithium is 3. So that equals 4. So we have 4 neutrons in a lithium atom. Okay, let's do the same thing with oxygen. Okay, I don't need my angel to erase this, but oxygen, we have an atomic number of 8. Our atomic weight is 15.99, so we're going to round up to 16, and we subtract that because in our nucleus, most of the weight of an atom is our protons and neutrons. Electrons are like 1/16 the size. So from a weight perspective, they don't add a lot. So we take 16 minus 8, and that equals 8 neutrons. The number of neutrons for our purposes, for our sophomore biology, has nothing to do with our charges. Okay, the only thing the charge influences is the number of electrons. Our neutrons are always the atomic weight minus the atomic number is the number of neutrons. The number of neutrons is always, for our purposes, a whole number. Fractions and decimals are going to be marked incorrect. So that's how you figure out proton, neutron, and electrons for all the elements on the chart. You just use these simple formulas. Atomic number is the number of protons, very simple. The neutrons is the atomic weight in whole numbers. You can either round it here or there, but atomic weight, minus the atomic number equals the neutrons. Okay? And for our electrons, it's our atomic number minus the charge. So if there's no charge listed, like here with our lithium, then the atomic number equals the number of electrons. Okay, so that's our review for chemistry for what we're going to be evaluating on our elements in biology in Chesterton. Thank you. If not, you end up with the cone of shame.